So this is the largest square algorithm. We're going to find the largest possible square in a 2D array of ones and zeros. We're going to define what is a square. So a square is where all of these values are the same. And how do we know if we have a square? Well, here's the coordinate system we're going to use. This is going to be xy. We're going to check x plus s, comma y, x, comma y plus s, and x plus s, comma y plus s, where s is a given size of the square. If all those values are the same, then we are all good to go. How do we search? Well, the array could be a square, and the array could be a rectangle. So that rectangle could be horizontal or vertical. Either way, we're going to have to search differently. So here's how the search algorithm works, at least the one that I've implemented. So for each of the x's, for each of the y's, for each of the sizes in the possible sizes, calculate the largest square. In this example, this is a vertical array, and this is how the for loop is going to work. We start at x equals 0, y equals 0. Then we decrement the size as we move through the algorithm. Eventually, we'll get to a 2 by 2 square, and then we increment the x by 1. So we move the x over 1 and do that. So if we are at x of array.length x minus 1, then we increment y. There might be a little bit of a different logic going on for horizontal arrays, but I'll go into that once we get to the code. Some optimization ideas. If we found a square that is 8 by 8 in size, for this particular example, where it is an 8 wide by 14 tall, so if we found an 8 by 8 square, end the algorithm. It's done. We can't find a larger square. So if the 2D array is vertical in shape, we should stop the search when the y value, so the y value here, plus the size of the current largest square is bigger than the horizontal length. Likewise, we should stop the search if the x value plus the size of the current square is bigger than the width of the array, because then we can't find any larger square. But that's only for horizontal searches. If we've already found a square that is 6 by 6, then we should stop searching for any squares that are smaller than 6 by 6. A couple of notes that we're going to have to think about when we write the code are, is the square that we have just found bigger than the previous largest square? And is it possible to even find a larger square? That goes into some of the optimization problems I was talking about. Anyways, that's how I went about thinking about this problem. Let's go into the code. So here I have a C# program to go over the algorithm. I have a function here that'll generate a random 2D array of integers, and it'll just be a 1 or 0. That will be put into this variable. We create a new solver class, pass it the array to solve for, and then we call the solve method. So let's look into the code that I've actually written here. So we have this class called algorithm. The couple things that you're going to need to know are the largest square, let's see, we have the search type, the largest possible index, and the array to solve. Those are the main ones. This here is for debugging. This here is for informational purposes, for calculating runtime. Yeah. So back into the constructor here, we set the solver ID, which will be used to create the file name for the image that we output. We have a largest square. By default, an array should have at least a square of 1 by 1. So the size is populated to 1. and the initial position is 0, 0. Whoops. So here we're going to calculate whether we should search horizontally or vertically. So if the width is greater than the height, so the x is greater than the y, we are doing a horizontal search. If the y is greater than the x, then we're doing a vertical search. The largest possible index is a helper integer that helps us not go out of bounds when calculating the largest square. So the largest possible index we could possibly use is the height minus 1. And for vertical searches, the largest possible index is the width minus 1. So that concludes the constructor. Then once we call that solve method, we write out some debug information where we log the x size and the y size, and then we find the largest square. So for each of the x values and for each of the y values, I created this helper method so I understand what I'm getting. All it does is call the get length 0, calculate the max size, so this is that s value in the PowerPoint. So if the max possible size that we can get at this particular x and y is greater than the largest square, then let's continue the algorithm. So create the corners. This will just create the coordinates as shown in the PowerPoint. And then try to grab those values from the array. If the values are all equal, and this current size, the s plus 1, or the s index plus 1, which is the size, is greater than the current largest square, then set the current largest square's top corner to the top corner that we're currently at, and then set it to that size variable, plus 1, where s is an index, so it's 0 indexed. That gives us the largest square. And then right at the end of the method, before we loop to the next y, we say, can a square be larger? And all that does is it checks the horizontal versus vertical search type. So if it's a horizontal search, and the x plus the largest square at size minus 1 is greater than the array's width, then we can't possibly have a larger square. If this is a vertical search, and the y plus the largest square at size minus 1 is greater than the length of the array, or the height, then we can't have a larger square. Otherwise, let's keep searching. So as long as this doesn't hit true, we won't jump out early. If we make it through the whole thing, it'll return true at the end and just end the algorithm. That will give us the that will populate this class, this algorithm class, with the largest square. And then for debugging purposes, I write out all the data to an image. So I have this that'll write out zeros to black and white, or the ones to white. And I have this method that'll create a red square around the largest square. And this is where that solver ID comes in, because I save, I do image.save and then solver ID dash highlighted, or just the solver ID. Now if we run it, it's going to run through a couple examples, and we can take a look at it. So I'm not sure. Yep, it'll allow us to zoom in. So as you can see, it appears to have worked. Now, the unfortunate thing with a lot of these random number generator things is when the numbers when you create a large enough array, it's really hard to see where the red lines are populated, because there's a solid chance that one of the first couple things is just going to be a big square around the outside. Anyways, that's the algorithm. If any of you get this challenge in an interview or want to prepare for an interview, this is a good one to take a look at. This is a big challenge for me to both do and explain. Yeah, leave a comment below if you have any questions. Thanks.